Okay, let's look next at the measurement capabilities within SolidWorks. Now, those come in two fundamental flavors. One of them are geometrical in nature. So we're talking about interrogating the model for distances, perhaps in between two holes, in between two facets or surfaces, between 2 points. We're talking about interrogating for angular measurements between 2 lines, 2 surfaces. Talking about interrogating for perimeters, for surface areas, things of this sort. Okay, and then we'll look at mass properties. So that gets into the issue of calculating the weight of the part, mass distribution of the part, as in where the center of mass or center of gravity of the part is located. And then certain even more sophisticated measurements, moments of inertia, which allow us to calculate forces, or rather torques, that would be necessary in order to spin a particular component or assembly to a given speed or acceleration. And that would in turn allow us to size an appropriate motor for the task. So very important capability as you can imagine. Now, one thing to state, right off the bat, is that a lot of these capabilities, in fact, virtually all of them, are really available at the part level as well as the assembly level. They're obviously more useful at the assembly level, insofar as SolidWorks can effortlessly keep track of all the different components, different materials, the material densities associated with them, of course, and generate all those calculations for free for us. Now, I want to, perhaps in my relentless style, bring attention to the fact to you that all of these calculations that where SolidWorks can be very, very accurate would have been hopelessly difficult to do in the past. You would have had to rely on approximations that themselves would have been very tedious and error prone to arrive at. And now it's just as simple as a couple of mouse clicks. So let's take a look then. First of all, even without going any farther, you can just at the model level here, just click on any feature, and most of the times SolidWorks is going to give you something interesting, or it's going to have something interesting to say about it. So for example, let's say that I select that circle, and you can see there just that by that mere selection, here we get on the status bar information on the diameter, the location of the center. Okay. Here I'm clicking the fillet, and it's giving me the radius of the fillet, and again also the center based on the prevailing coordinate system. Same thing here for a line. It's giving me the length of that line, 4.5. And here, if I click that other line, 7.5. If I click the surface, it doesn't provide any information, but the measurement tool, which we'll look at here shortly, will. You can even extend this to clicking 2 features. So if I select here the 2 circles, notice that we are going to get the distance between the circle centers, so-called center-to-center distance. Okay, and if I select one line and then here another line, and those 2 lines happen to be parallel, if that measurement makes sense, then we are given a normal distance between them. Okay, and a total length, which would be the sum of the length of each individual line. So 4.5 plus 4.5 there. All right, so that's without going any farther. Now the heavy duty item in here to get answers to your questions measurement wise is this tool in here, this measure tool. Okay. Now the measure tool looks deceptively simple in here. It doesn't look like it's doing much, but it's a bit of an empty canvas in which you can throw in there a different geometry and it'll just figure out what to do with it. So let's say, for instance, that I just select that particular surface in there. Well, just by clicking that surface, we get, of course, the description of the particular feature, and then here we get an area, so surface area, and a perimeter. Now, usually you can chain multiple features. So, for example, you can click on that face, this face, and that face. This is without holding the control or the shift key. And what it does is it'll collect information and give you the aggregate of the different features that have been selected for those quantities that it can compute. So in this case, it would be the total surface area. Now, if, for example, I select that face and then this other face, here now we get not only the total area as before, but we also get a distance. Okay, so far as again a distance can be extracted, from these two parallel surfaces. Okay, so notice that now you're getting the true distance between those two faces, 5. Which is not dependent upon the fillets. So in other words, if we had selected that edge, that says, of course, 4.5 because it's not able to take into account the radii of the fillets. Okay. Now, just as easily as you can select lines and surfaces, you can also select individual points. So say, for instance, we selected that point and then another point up here up on top, say consider, for example, one there. Okay. So we've selected a point here at the base, at the very, very base, the bottom of the base of the part, and then one at the very, very top. Okay. Now, in this case, since these points are not aligned along the normal axes, the XYZ axis, what we get is a breakdown of what the increments are along each one of those axes. Okay, so we're going 2.062 inches along the Z, then here 5.125 along the Y, and similarly across the X. Interestingly, we also get an overall distance. So this, of course, would be the square root of the squares of each of those distances. Now, this particular measurement is unlikely to be useful, but oftentimes that is exactly what we want. So we have all that information given to us by SolidWorks. In some cases, we may just want to look at a Z offset or a Y offset or an X offset. In some other cases, we may want to consider the overall distance in there between the 2 points. And of course, all this is being reported faithfully by SolidWorks. Okay. What other things can we do? We can interrogate the circles in a more expansive manner than the way that what we saw before. So for instance, I can select those two features and I get by default the center to center distance. In this case, 6 inches. Now, let's suppose that I wanted to look at those two circles and figure out how much distance I have in between. So I may not be content to just have a center to center distance. Well, easily done. Okay, so here under arc or circle measurements, you can in fact select a minimum distance, maximum distance, or even a custom distance. In our case, we just wanted the clearance between the two holes, so we'll select minimum distance, and we see that it computes to 2.125 inches. We can also interrogate the model for angular distances. So for example, we can take this line in here from the rib, one here on the base, and we will get an angle between the two, 66.5 in this case. Now we also get some distances that are computed here, which we can safely ignore. Just be mindful when you do this that sometimes you may get the excluded angle instead of the included angle. So in this case, if we select those two surfaces, we're getting the 113.5, which would be a 180 minus the previous result. So this is all rather straightforward. About the only interesting point to make in here, in addition to what's been mentioned, is, well, a couple of things. First of all, we can control the system of units. So if we select, for example, this surface here, and we decide that we need to have that area in millimeters squared, we can come here and control the units. So say, for instance, millimeters squared, just for the fun of it, and there it is. Okay, so that's just a simple modification that you can do here within this box without having to go back and change the units of your document. Then we also have this utility called point-to-point. So this is in situations where we cannot, or it is for whatever reason difficult to select a particular point in the geometry. You can just estimate it in this manner, just dragging it over the geometry. You can even go elsewhere in the part and just sort of eyeball, where you wish to take the measurement. Okay, so that would be applicable perhaps, for approximate measurements. There are other utilities here related to projections. We won't discuss them now. You can also keep a running tally here of all the measurements that you've taken. So this is all, again, fairly standard. Let's now talk about the mass measurements. Okay. Now these are all under mass properties here, so right next to the measurement, which was related to geometry alone. Okay. First thing to say about the mass properties is that they can be calculated for the assembly at large, okay, or you can select individual components, and you can treat this just like any other selection or geometry selection box in SolidWorks. Okay. So we'll go back here and deal with this at the assembly level and delete that, but just making sure that that is taken into account. You can in fact also decide whether hidden components in your assembly are included in the calculation or not. Okay, let's begin with a simple easy one, create center of mass feature. Okay, so if we select that and minimize the box, we'll see that we have a classical center of mass, center of gravity notation there created in the viewer. And what we see is, if we look, for example, at a front view, we'll see that the center of mass for this particular unit happens to be a little bit below what you would think of as the geometrical center. Okay, so this is easy to explain. Obviously, there is quite a bit more mass below that plane that there is above, so we would expect that to be below. Might also be a little bit pulling to the left. We have a little bit more mass here on the left and on the right, but that would be perhaps a minor thing to look at. We can probably pick it out if we have a proper symmetry plane in there. So if we get close enough, we'll see that it's a little bit to the left in there. Okay, just as we expect. Now, if we were to look, for example, at a side view here, we would expect the center of mass to be fairly close. There's also perhaps, there is some uneven weight distribution in there because of the location of the shaft, and so forth. Okay, so an interesting thing to carry along. This becomes a feature on the tree, and you can delete it if it bothers you. Okay. What else do we have under mass properties? Well, certainly when you calculate mass properties, you get a wealth of information, the most important of which is going to be just the raw mass and volume numbers. As we said before, we can come back and calculate these with different units. Just go here to the options tab, and you would be able to switch the units without, again, having to bother to go through the options menu in order to change the units for the entire document. Okay. There's, by the way, the calculation of the center of mass, also total surface area. In some cases that may be useful. Okay. The other important, very important calculations are these principal axis of inertia and moments of inertia. Now, we're not going to explain here what this means exactly in physical terms. This is something that you would learn in your dynamics class. The important thing to know is that these characteristics are essential to being able to size motors and actuators for rotary systems, and even to being able to establish other engineering characteristics of the part or the assembly. Okay. So again, we won't look into them, but I would suggest, perhaps as an exercise, to take, say for instance, a simple geometry such as a box or a cylinder created in SolidWorks, assign a particular material to it, or even without the material assignment, this you would get an adequate result, and find things out like where, or rather, what the value of a particular moment of inertia is around a certain axis, and then compare it with tabulated values that are, again, for simple geometries, so cylinders, spheres, cones, boxes, in your appendix in your dynamics book. So that's I think an interesting exercise to go through. Now we'll round up this exploration here of mass properties with one last important subject, which is the ability to establish and select the particular coordinate system about which you want to report certain numbers. Now, you can imagine, of course, the mass is fully and wholly independent of the chosen coordinate system. Same thing with the location of the center of mass, surface area. All this stands to reason. Not so, however, with moments of inertia, or even if you want to be able to report the location of the center of mass relative to a particular location of your choice. Okay, so far we've been sort of blithely going along here with this default coordinate system. And the default coordinate system in this case, in absence of anything else, is just going to be wherever the origin of the assembly happens to be. Okay, so if we come here and if we highlight the origin of the assembly, well, you see the point right there. Okay, and that's where the assembly is. Okay, and the XYZ coordinates would be as shown here in this icon. Now we can make all that very explicit, okay, by creating a coordinate system using reference geometry. Okay, so here's the reference geometry. I just went to the assembly tab. Okay, select reference geometry, and now we can use this coordinate system option, which was kind of lying dormant before. So if I select a coordinate system to lie at the origin, okay, then that's exactly what I would get. By default it is aligned, but notice that I can switch the alignment in here of the x-axis. Okay, so you can see it moving there, and same thing with the y-axis. Okay, so I can select the origin and then subsequently the orientation of my axis at will. Now, if I wanted, for whatever reason, to be able to report the center of mass of this part relative to, well, let's say an origin that was located here at the center of the input shaft, okay, what I might need to do in that case is to create a point there at the center of that face. Well, again, that's available through reference geometry. Okay, so in this case, I might want to create an axis just simply by selecting the circumference of the shaft. Okay, and then I might want to create a point here again under reference geometry. So create a point, okay, which lies, for instance, at the intersection of that axis, and then a face here. Now this is, I guess I could have also selected the center of the face as the point for my axis, so I have an extra step in there, but nothing else, just to illustrate the point. And now I'll take a coordinate system and make it coincide with that particular location. Again, I can align the axis however it might be convenient for me, if that's what I like. I have now created a new coordinate system 2. Okay, and now if I wanted, for example, to find out the location of the center of mass of this entity, which of course is non-varying, or at least not until we move something in here. But if I wanted to find out, the location of the center of mass relative to a different coordinate system, well, I would just go to the Evaluate tab, Mass Properties. It's asking me for a rebuild. And now notice that I'm free to select a new coordinate system, and notice, of course, that the location of the center of mass will change. Okay, one more time, if we go to default, we'll see that we have different center of mass coordinates. Okay, so this matter of being able to select a coordinate system may indeed come in very handy for some of these more advanced measurements that are taken under mass properties. All right, so hopefully this has been useful to see what all is available, again, for free through the SolidWorks interface, and hopefully put it to good use.